In this demonstration, I'll show you how to perform the substitution method for definite integrals. This is part 1 of the series. When it comes to doing this, you have two options. In question number 1, I'll show you option 1, and I'll use the exact same function for option 2. In this option, you deal with the indefinite integral for convenience and then return to the definite integral after we finished integrating. Here's what I mean. Let's start off by setting this equal to u. U is equal to 5x squared plus 1 dx. We're going to derive both sides where we get du is equal to 10x dx. Next, I'll solve for dx. Dx is equal to du over 10x. The next stage is to substitute a u and this into our function, where we have 2 as our upper limit and 1 as our lower limit, 3x u to the power of 2, this thing, du over 10x. This cancels out with that, and we end up with 3 over 10, the integral between 1 and 2 for the function u to the power of 2 du. The next thing is to find the antiderivative of u to the power of 2. U to the power of 2 has an antiderivative of u to the power of 3 over 3. And I'm going to substitute that back in where we have 3 over 10, this thing, over 3, and the 3's can cancel out right away, plus c. So we have u to the power of 3 over 10 plus c. The next step is to bring back what we set u equal to. And if we do that, we have 5x squared plus 1 to the power of 3 over 10. And now we will evaluate this at both 1 and 2. So let's do that. Let's evaluate it at 2 first, since we do have to subtract the antiderivative of the upper limit from the antiderivative of the lower limit. So starting off with b, we have 5 times 2 to the power of 2 plus 1, all to the power of 3 over 10. And then similarly, instead of this 2, we'll use the 1, our a value. 5 times 1 to the power of 2 plus 1, all to the power of 3 over 10. The first term simplifies to 21, and then to the power of 3 over 10. And the second term simplifies to minus 6 to the power of 3 over 10. And there you have it. That is the answer for that function. Now let's try option 2. In case you're not content with this one, you can always use this one. And in this case, you'll do pretty much the same thing, except you will find new lower and upper limits by evaluating only the u at those lower and upper limits. Let me demonstrate. U is equal to 5x squared plus 1. That doesn't change. And we're going to evaluate this at both 2 and 1. And the answers we get for both 2 and 1 will become our new lower and upper limit. So at x is equal to 2, we end up with 2 times 2 is 4, times 5 plus 1 is 21. And at x is equal to 1, we end up with simply 6. So our new upper and lower limit will be 6 and 21. So let's do that. The integral between 6 and 21 is equal to 3x. And remember, we set this equal to u. And if you recall from the previous example, our dx was equal to du over 10x. That doesn't change. Next, I will cancel out these two x's. Bring out 3 over 10, 6 and 21, and we have u to the power of 2 du. And the next thing I'll do is find the antiderivative of u to the power of 2, and we already did that above. It was u to the power of 3 over 3, and we ended up with 3 over 10 u to the power of 3 over 3. These two 3's canceled out, and we have plus c. Now what we'll do is evaluate this at 6 and 21. Notice that I'm not going to change the u back into my x. Let's do that. 21 to the power of 3 over 10. That's using the upper limit. Now using the lower limit, we have 6 to the power of 3 over 10. Now, doesn't this look familiar? Take a look at option 1 and take a look at option 2. That is how to find the area underneath a function for a definite integral using u substitution. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.